Hi, welcome to the video on making the spreadsheet for the reactions rates lab. So if you did the virtual lab, this is the data that you are going to plot, and then you're going to use your plot to answer Postlab question number 2. So in Postlab question number 1, we need to first create the graph. So what you're going to do in the x-axis, your independent variable is the volume of sodium thiosulfate, and the dependent variable is your reaction time, so that will go in the y column. So you're going to have this in your Excel spreadsheet, or your, sorry, I should say Google Sheet. All right, I'm going to highlight my data, and then I'm going to go to Insert Chart, and then I get something that looks like this. Now, this is not the chart I want. I want the one where I have reaction points. So I'm going to go ahead and click on my graph here. And as soon as you make a graph, this chart editor should pop up, and I'm going to go to underneath where it says chart type and click on that, and then I'm going to go to the scatter chart. So now we have lines. All right, so this looks decent, but I want to connect the lines in an exponential decay because reaction rates occur via exponential decay. This is not a linear graph. So for that, I'm going to go to Customize, and then I'm going to go to Series. You got to scroll down, click on Series, and then click on Trend Line. Now the trend line at default is linear, so I'm going to change that and click exponential. And then now I have an exponential graph. Okay, so you have your plot now. What you're going to do is you're going to click on that, Control-C, copy it, and then you can paste that directly into your lab document. Okay, so here's my copy of my lab document. Assume that all my data is in there, and you're going to go ahead and underneath one, you're going to paste. Now to paste it, I would recommend pasting it unlinked, so that means that any changes you make in the spreadsheet will not show up here, so you just have to change that accordingly. All right, so that's question 1. Now for question 2, what you're asked to do is you're using this plot to determine the reaction time when the volume of sodium thiosulfate is 18 milliliters. So here we have the volume of sodium thiosulfate on the x-axis. So what you need to do is you need to find where 18 is, and you can estimate that. So it's somewhere between here and here. So you can estimate that, and then find the corresponding reaction time. So for me, it'll be, I would say maybe 0.7 minutes or something like that, 0.8 minutes. You can, of course, always add more grid lines if you want, or the other thing that you can do if you want to be extremely precise and extremely accurate is add the equation for this trend line. So to get to the equation for the trend line, underneath trend line, when you first make your trend line, it says there's label and it says none. So you go to use equation in the drop down menu, and this is the equation. So for our situation here, the function is y is equal to 11.3 times this Euler's or Euler's constant, which is that script e above the natural log, raised to the power of negative 0.139x. So what you would do is you would plug your value in for x, which is 18, and then times negative 0.139, that will be the power for e that you would use, and multiply that value by 11.3. So you can also use the equation if you want to be accurate. All right, hope you found this video helpful. Have a quality day.